that okay? Like, is it clear, more clear now?
Yeah.
Are you okay?
Yeah.
Okay. So, some of you ask about the expand function. So this is actually like we wrote, but you can do this with like for loops. Basically, this is the expand function. So we are declaring a new array using dynamic array by multiplying capacity over like times 2. And now I'm just checking because there are certain situations here. You can do this with two, three for loops. So this is your array, and assume that it's just full. And front shows here. Sorry. Front shows here. Back shows here. And these are all full. Something, some value in it. And now I need to create a new array, which is going to be double the size of it. So in dynamic arrays, what we do for expand function, first we declare. Second, we just copy it from previous array to the other array. And then for third, we delete the previous array. For the fourth step, we just update the pointer to show, okay, we did this, now we saw our new array, we deleted the other one, so this is your new thing. So basically, front can be here for one case, back can be here. So you can start with for loop. For, you can say, I starts from front and goes to back, I++. So what is the problem in this for loop? It doesn't include every single element in the array. So some of us did a mistake in the lab with this, just thinking that front is always pointing here and back is always pointing in the end. Yeah, that's true. If front is pointing to the beginning, I will go until the back and I will copy all of them. But I might just, there are cases. I added from the front, I added from the back, I removed, like it just moves. If I start from front and back, it will only include here. So you should be able to do a loop that includes here and here, or after the back, if that's the case. If you want to copy your, that's what you need to be focusing on. And the else situation here, which means back is pointing here, front is pointing here. So in the else, you need to do a different version of for loop. Or there's a command called copy, but I'm not sure if I need to show this.
Actually, instead of showing it, we could just tell you what it does. So in here, it first checks for if front is bigger than or equal to back, right? It's this case. If front is bigger than the back, what you have to do is copy these and then copy these. That's how it should work. Because you want to copy everything and you want your front to be here, as you can see, front is set to 0, and back to be the end of the copied values. To do that, we had this if, and copy is a function that say you wrote somehow that copies from sequence array plus front. If you just don't think about sequence array, what this is saying is start from the front, copy until capacity right here, start from the front, copy until capacity into the expanded array. So this could be a function that you wrote. And then what it does is it starts from the beginning of the array, because just like think this is a 0 instead of sequence array, just put zeros in your mind. This would start from the 0 and it would go until the back here, and it would copy them into the array again, but from the place it left. This is a memory function that you didn't learn and probably are not going to learn, but this is basically what it does. if you could think about you could think of it as if it was a loop that was going through the elements starting from here until here and copying them into this array.
We have a question. We don't? Okay.
So that's what it does.
Here, basically, the copy command is just simple, and we basically do this. We rearrange our array with showing like front here and back wherever it was, and we basically update our index values here, as in saying front is equal to 0, back is something back from capacity, how much I went back. So now, like we saw arrays, we saw dynamic arrays, and we just learned how to point front and back with indexing them using index values. So where it comes to the data, another data structure is called like stacks and queues. For stacks and queues,
Does anyone have any questions about this?
Yeah, we are jumping to another topic now. Eraser.
So there'd never be a case where there's something between front and back, right? Like,
Well,
I mean, like right there, like, right? You said like we're gonna
This
go
one?
from like. And
Yeah,
now when you
this
go
means
front-
that there are only 3 elements. Yes. If there was something between them, it would be like this.
Oh, I mean, it would be like the other way up.
Because it's the front and the back. It starts from here, goes on to here.
Okay.
If it's full,
Yeah,
they would both be at the same.
Go ahead.
Got it. So in that
And then we
case,
can
you're
go
just
through the problem
going
if you want. I can
from
go
front
through
to
it.
the to 0, and then from
Because like I did
capacity to
yesterday,
the back.
This one?
fully
Yeah.
confident.
This is actually this is not like
Confident in this.
the only elements would be in these 3.
Oh,
Because
it would
this is
be
the
those
front,
three.
this is the back, so it will go like this.
Got it. Okay.
If anyone was confused about the previous example, here, if front is here and the back is here, there are only 3 elements which are in the middle, and you have to copy those. This was the else.
Okay.
This was the
Let's
else.
wait a second. Now we can.
Okay, so basically, I'm gonna do a quick like reminder of stacks and queues before jumping into the actual review problem. So people find this helpful. So for a stack, I think of it as a stack of papers. So if you have a stack of papers, you can only like remove from the top piece of paper. So for a stack, you normally push onto the top and pop off the top of the stack, so you're able to access like the top of the stack in an order 1 operation runtime. So again, like thinking of a stack of papers is really helpful because like you can only remove the top element. You can't like grab a piece of paper from the middle. And then we also have a queue, and the basic operations for a queue. I like to think of the phrase like queue up, like form a line. Because if you think about if you form a line, like the last person in the line like waits until they get to the front. So for a queue, you NQ onto the back and you DQ off the front. So for example, like if we have something that is going on a queue, we put it at the back of the queue, and we can only DQ that off the queue once it is at the front. Does anyone have any questions before I move into an example? Cool.
Any general questions are also fine. Like, what is a queue? What is a stack?
Yes, like please feel free to ask. Like here is a review session. We are not doing something like in terms of grading or like telling, okay, this person doesn't know anything, like we were going to tell the professor about it. No, just feel free to ask anything you want in your mind.
And these are abstract data types, and if you feel like they're too abstract, it's fine. We will help you to understand the fundamentals of it. You were going to ask a question.
Yeah, I might be just confused, but when you NQ, is it up towards the back?
This is the back.
So that's the back?
You could write that. That's the back.
Can you tell me like LIFO and FIFO?
Yeah. Okay. Do you guys remember the term LIFO and like FIFO? So basically, FIFO is first in, first out. So like, for example, when you form a line, if you're the first one in the line, you're the first one out.
That's true.
I always mix them up, yeah. So a queue is FIFO and a stack is LIFO. So FIFO, what we just said, is first in, first out. So like you're first in line and then you're the first one out. And then for a stack, it's LIFO, which is last in, first out. So like it's the opposite. Like if you have a stack of papers and you put like the last piece of paper at the top, that's the first piece of paper to get removed. I always mix up LIFO and FIFO, so I first think of like stack of paper, queue up, form a line, and then I like work from there.
So the behavior of those two data types, data structure types, are highly important, because like we just implement our codes according to that, like FIFO and LIFO. Like last input, first output for the stack, and first input, first out for the queue. So with knowing those things, you can basically implement your simple stacks and simple queues with the functions we have from the lab, like add from back, add from front. This is actually what you're doing in the stacks and queues, without having this stack or queue abstract data types. You're just doing it by yourself. That's what we have seen in the lab 3 actually. Like we literally implemented from scratch. So we have another question with the pops stacks. You want to do it? Or?
Yeah, I can do this.
Okay. So this is an exam question too from that year. And
This is our exam question.
this is your exam question?
Back in the time.
Okay.
Oh, I remember it. Yeah.
I don't know where you can take it from. Well, you can also use this if you want.
Yeah,
and
I can.
I'll also add something. Sometimes people are like, okay, we have stacks, we have queues, like, but why would we use them for anything? And when people get confused about that, I always think, like, the line example is a really good one, because let's think that you went to Kindleton to get like a smoothie or something, and while you're waiting there, someone just like cuts in front of you, and then you just have to wait more, but you were the first one. Would that make sense? No. That's why you would use the queue. But for the stack, let's say you have like a stack of papers, as Hayden said, or like some music you have. You would play the most recent, let's say you play some music more than others, right? You would like to have the access to that easier than others. So whenever you play that, whenever you pop it off, you would also like to push it back and take it off again. If you put that to the last element, then you would have to go through everything and then just take that again. You would use the stack for cases like that, when there are some recent things you use and you want to keep using them. That's how I try to explain why we would use stacks versus queues and stuff.
Okay, so for this example, since I don't know if everyone's read it, essentially we have two stacks and we want to use our two stacks in order to implement a queue. And again, like the whole point of abstract data types is like the client like doesn't know how you are using that, like that you're using two stacks in order to make a queue. All they know is that you have a queue that they can use. So for this example, we have these three functions for a stack. We have pop, push, and is empty. Those should be pretty self-explanatory given what we just went over. And basically, we want to create a stack queue class using, like queue using the stacks. So basically, what we need to keep in mind is, again, that a stack, I'll just draw it again, like you push and you pop off the top of the stack, and then for a queue, we want to like be enqueuing and dequeuing. So, for example, if we want to remove from a queue, right? So we need a way of saying like, we have two stacks and we need to keep track of like stack 1 and stack 2. So let's say S1 is going to be the one that we're going to always like dequeue from. And I'm gonna say that I'm gonna like put stuff on stack 2. So just starting out, I'm gonna be like, okay, whenever I remove something, it's going to be on stack 1. So when I dequeue from my queue, I'm just gonna pop off stack 1. And that's just like a decision that I'm making in my implementation. So this one, I'm gonna just return what's on the top of stack 1 using, oh, sorry, I'm left-handed, the pop function. And that's just a decision I'm making because I decided I have this stack and I'm going to use it in order to DQ or remove off of my queue. Okay, if this is a little bit confusing, it might make more sense as we go through more functions. Does anyone have any questions at this point? Yeah.
What would happen if S1 is empty?
Yeah, so technically I was thinking the answers don't have this, but you should check if stack 1 is empty before you pop it, because otherwise there would be an error. So if you were like really formally implementing this in code, you would check if stack 1 is empty, and if it is empty, then you just like return, and then otherwise you're gonna like pop something off the stack.
Okay.
So that was like a really good point.
And also the stack itself could be implemented so that when there's nothing, it wouldn't pop. We're just using the stacks right now.
I'm confused. Is this a stack and queue?
So we are using stacks to implement a queue.
Okay.
Like this comes up in interviews. This was a exam question. Actually, this wasn't my question. My question was to implement the otherwise. We implemented the stack using queues and stuff. So these kind of stuff will always come up.
So professors like it a lot.
Yeah. Yeah.
Could you maybe draw what that would look like? How would the two stacks like interact
Yeah,
with each
yeah.
other?
So I think like you'll have to bear with me a little bit throughout this example. So let's just pretend that I have this stack 1, and then I have oh my god, another stack 2, and then I'm using these two in order to implement the queue. So I just decided, like in the remove example, that I'm gonna use stack 1 in order to remove. So keeping that in mind, I need to know that whenever I want to implement a DQ operation, all I have is popping off of this stack. So I need to like be like, okay, stack 1 is going to be my remove stack, and stack 2 is going to be where I'm going to put elements on. I think like once we go over push, it'll kind of click. This is like a really weird thing if you've never seen it before. But again, like I mentioned, I'm pretty sure I've seen all of these questions on a website called LeetCode. Raise your hand if you've ever used that. No? Okay, so it's this really great website, and these I think are all in like the easy and medium, like you've used LeetCode before, right? These are all in the easy and medium section, so I can almost guarantee you that there are examples like very similar to all of the ones that we've gone over, because these are just like classic questions of testing, like do you understand data structures? Moving on, so let's pretend that I want to now implement push onto my queue, which I don't really like the name because it's more kind of like NQ onto my queue, and it makes it a little bit confusing because you're like, am I pushing onto a stack? But you're actually like, this is to put something on your queue. Are we good with that? Cool. So basically, in order to do that, I'm going to remove like everything from my stack 1 and put them all on stack 2. So I have stack 1 here, right? And I'm using stack 2 in order to put things on my queue. So I'm going to take everything from stack 1 and put them all on stack 2. So if I want to take everything on this stack and put it all on this stack, can someone tell me like what that like might look like? Yeah. Do you have a question?
Oh, like the code?
Yeah, or like just any thoughts you have?
Wouldn't it just reverse the stack so then you can pop it off to the top?
Yeah, exactly. That's like essentially what we're going to do. Yeah, so that's, yeah.
No, it's kind of like, I think they said this in class too, like the ring, like if you have two like holes with the rings.
Yeah, exactly. That's such a good way of thinking about it. Like, because we want everything kind of like in reverse. So like if you have a stack of rings, right, like with these, like if once we take this ring off, then that's gonna end up at the bottom, and then this guy is gonna end up like here. So then they like reverse order.
Since like the behavior is like LIFO, last input, first output, when you use like two stacks, when you pop from one of them, you will take the top one and then when you want to add it to another stack which is empty, you would put it in the bottom, and then this way you end up reversing them.
Yeah. So we have this element x that we want to put on our queue. So like we just said, basically we're going to remove from stack 1. So like think of the rings. That was like a really good example. So while our stack 1, we have an isEmpty function. So while it's not empty, we're going to keep on removing everything from stack 1, right? And what are we going to do with those things from stack 1? Does anyone have any thoughts? Yeah.
Push them onto S2.
Yes, exactly. Push them onto S2. And so we're going to take all the things on stack 1 and push them onto S2. Does that make sense? Yes.
But I'm sorry, I think I already said this, but this is actually like a on queue function. Right?
Yes, it's enqueue. I'm not crazy about this name because
Yes.
like push is like.
We are creating
yeah.
enqueue with using 2 stacks, basically. That's what we are doing.
Yeah. Okay. So exactly what's your name?
Robbie.
What Robbie said. So we're gonna take stack 2 and we're going to push on what we've popped off of stack 1. So if I want to pop off stack 1, it's just S1 dot pop. And so that makes it so now we've taken everything on stack 1 and pushed it onto stack 2. Are we good up to there? Any questions or thoughts or comments?
I did have a question for when you're checking if it's empty. If you have a data type of element, so you don't know specifically what it is, like whether that's a pointer or something, what would you return if it wasn't? So like if it was a pointer, it was an empty list pointer, so what would you return if it was like element X? If it was exactly what the data type was.
We can return null.
I don't think I understand.
Like
Yeah.
if it is empty, what would you return?
Oh,
This-
yes.
This doesn't return anything.
Right, yeah, I'm talking about in general, like what is empty.
In general.
Or,
Oh,
like,
the is empty
other
function.
functions, like,
You could throw there.
If it's empty, then it's empty. If it's so this is empty function is actually implemented in the stack that you're using as a client. So that's the choice of that design. You don't really care about that. But if this is not empty, you're going to just push this element X to your own stack queue.
Do you remember when we were doing the homework too? It's for linked list, but when you remove like all of them, all of the stations, for example, and when you're checking, okay, is there any station? Like if head is null, for example, it's an edge case. It was an edge case. If head is null, just return station S. Station S was like a constructor with no name and access is false. Basically, you are saying it's null, there is nothing in it, but this is not the case. Please.
So is S2 dot push a different push function than the one that we're writing, or is it recursive?
Oh, it's, yeah. Let's pretend that this is enqueue, because they technically, like, you wouldn't have a problem with it being recursive because they're acting on different classes, but no, it is not recursive, so let's just pretend this is called enqueue
Yeah,
for the
the
sake of
function name needs to be changed here. Yeah.
Yeah.
You're sorry about that. Like we basically just copied and pasted it, and yeah, it should be a different name.
Okay, the other question.
Since you're passing in an element called X, shouldn't you be addressing it at some point?
Yeah, we're not
Yeah,
done
yeah.
yet. We're not done
Oh,
yet. Don't worry.
This is not over. This is not over.
Yeah.
So we're going step by step to.
So this is like step 1 that we just did right now. So that leads, oh yeah.
Sorry, are you putting the what you pop off from stack 1 to the front of stack 2 or like in the back?
So you have to remember that with stacks, like we said, if we're popping off of here, like I actually like the rings more because the rings essentially are a stack, right? So if we have like these rings, when I take this ring off and I put it on like a new pole with rings, this ring ends up like at the bottom, right? And then this ring ends up here, and then this ring ends up here, so it like reverses them.
It's last in, first out, behavior same, but since there is nothing, when you push something, it's going to be the first element. For the second one, it's going to be on top of that.
Okay, so our next step, like someone was mentioning now, is going to be to push our new element on stack 1. Because we right now have cleared off stack 1, so we're like safe to put the new element on. stack 1.
So can I just interrupt
Yeah.
quickly? So we just pushed the, like we emptied the stack 1. Okay. Now the information is in stack 2. But why are we pushing the element x to the stack 1?
So that it'll be on the bottom. Like,
Yes, it will be on the bottom, and basically you cannot just put the element x into the bottom in a stack when you're using stack functions. So we are doing a queuing. That's why we needed that. We needed to put the x into the bottom. That's why we emptied the S1 stack first to the S2. Now we will actually do something there. Yes.
So this is our current state. We have stuff on stack 2 that was previously on stack 1. Those, if you think about the function in general, will be a bunch of elements. And stack 1 just has x on it. Right? Okay. So our last step is basically now taking everything from stack 2 and putting it on to stack 1. So now, basically, that's going to be look very similar to our first function. So we have, well, not stack 2 is empty. Then can someone tell me what we're going to do?
This one dot push,
Mhm.
S2 dot push.
Exactly. Yeah, it is really stupid, whoever said that. Like, it's a good exam question, but like, in reality, you would never want it. It's like...
I will see you in the exam that if there's something like this.
Like...
Or sets to, no.
I know, I'm glad...
This
yeah.
is practicing, that's
Yeah.
the important point.
It's good that you recognize that it's stupid, though, and that there are more efficient ways to do it. So, thumbs up for recognizing that. So, at this point now, we have taken everything, all our stuff on stack 2, all this, and we're putting it on stack 1, so now x has ended up all the way down here, and like stuff is all here. So, does that make sense to everyone? And now we have a queue.
Yes.
Yeah.
Yeah, so at any point after any like function call, everything should be in stack 1.
Yes. Yeah, because right now stack 2 is empty, and stack 1 has everything, which is why we said that stack 1 is going to be our DQ stack, because now if we like DQ off of stack 1, then we will get the proper DQ operation. It's kind of cool. Does this make sense to everyone? Okay, so back to runtime. What is the runtime of each of the above functions in big O notation? So like, let's start with remove. Yes. Yeah. I'm not sure what the exact answer on the exam was. Like, I would probably put order 1 for.
Yes, for
Yeah.
big O notation, like inserting something is basically constant. You just insert. And when removing something, it's in a while loop. So you just run through all the elements until it is empty. So which means a linear function. It's all big O n.
Yeah.
So remove is big O n for runtime.
Yeah.
The amount of time that you need to run your program. So in the classroom, the last class, we talked about how much memory space we need for that, but that's in another topic. It's not for here.
Is remove technically order 1 or order n? Like,
Remove should be order 1.
yeah, that's what I was
Because that's how
thinking too.
stacks work. And the important thing about stacks and queues is that when only pushing or like, can you go to the remove one?
Actually, this class I changed
It's
a little bit.
Yeah, popping off a stack is
I
order
changed
1
the question.
because
That's why.
that's actually why we use them.
I changed the question a little bit. Don't worry about the big O notation part of this one. We should have deleted already.
Ignore.
You have a question?
Well, I was gonna ask for insert would it be 2n because it's too long.
Yes.
Yeah, that.
Yes. But
You would say n. in
2n
that
is
case.
just, we are after n. That's the worst case scenario. Like 2n is n.
Question, so we have a question like this about stacks and queues, like their runtime. And can we go over that?
They can ask you, like, for example, okay, like here, there's a while loop, which means that you have a stack here, there are elements in it, and each time when you like pop something, you need one step, right? But you don't know how many steps, like, cause like your stack is large, you don't know how large it is. So linearly, you will go over everything since like it is null. That's why you will do this job n times here. N times, maybe you will do this n times, you will do this n times too. So it's basically happening in the same time, n times, and this is just like, say, constant. If you do this, it's going to be n plus 1, but we are not after the plus 1, we are looking for the worst case scenarios. This is going to be the n2, so it's something like 2n plus 1 or something. Should be something like that.
But
I am not 100% sure. I totally forgot my algorithms class that I took 8 years ago. So,
like, if someone was smart, they would use a stack when like they know that they need the thing at the top. So for example, if you think about like the undo button, if you're in like Microsoft Word or something, like that would be a good example of using a stack, right? Because you want your most recent action is like at the top of the stack, right? And then when you hit undo, then it's gonna pop that most recent action off the top of the stack. So like remove for that would be like order 1, because like we know it's at the top.
so now we have a similar example. Let's see the other example. It is like, I would love it to be an like exam example, like something like this, because it's still stupid. Yes,
I have a
Adelaide?
question about the runtime of like the second queue. I don't understand how it's possible that for like if you were to do an array list, it would be the for loop would be linear, and when you're basically like iterating the same kind of way through it as you would for a stack or a queue, which is O1.
Oh,
Like
that's not O1 though.
That's not
What are
the
you?
stack and queue.
We're assuming that we're only, like if we say that it's order 1, we're assuming that we're using a stack just to grab the thing at the top. If for some reason we decided to be dumb and use a stack despite the fact that like we don't necessarily need the thing at the top, it would be the same. It's the underlying structure is an array and it would be order n. But like, yeah.
And no worries, I will update Professor about this. Like, we have a little confusion, and like for pop push, like which is O1, which is ON.
Yeah.
I can tell him, and then we can go through it again in the class
But
or
like
after
in a
class.
stack, if you were to try to access the bottom,
Yes.
it had to go all the way
Yeah,
through,
we will
that
go.
would be over.
Yeah, I will
Yes.
let him know, and we should just like from now on we should move, because like we are running out of time and we need to be able to move on. No, I didn't mean me to. No, no. sorry. So now we have another silly one. One stack and one queue. This time, queue is non-empty queue, which means it's filled in with something, some values in it. And how? Like first in, first out. For example, if this one came first, this one will go out first, second, third, fourth, fifth, whatever. Let's say queue. And we have stack, and it is empty. So we will be using only this stack and a single element x here that I defined. It says write an algorithm to the reverse order of the elements in here. So what should we do? We are again still doing the same thing. We are transferring from some data structure to another one, and then I will take it back. So which means that I will run it like again 2 times, which ends up in 2 while loops again. So let's start with first while loop. First while loop is going to be this. The queue is empty because the queue is full right now, and I want to empty it to the stack. So what I can call is, I will assign x q dot dq. Is that the correct way to write?
With an E at that.
Yeah. So I dq'd the q, which means that first, if I first inputted this one, I'm taking out this one now, right? Okay. Then I'm going to put it to S stack, S push, X. Within the while loop, basically I will take this one, then this one, then this one, then this one, and put it in the stack. Yes, please.
How do you know the S is already empty? Like, should you check?
The question says S is empty. The question says I'm going to give you something, Q full, and oh, it's okay. Non-empty Q and empty stack. So we are playing. That's why I said it's silly. It's dumb questions. Yes, sure. Go ahead.
Do you need to use X, or could you just do like S dot push and do that?
I mean, the nature of question is that like they gave me X. That's why. Yes. Yeah. You
There's
don't.
nothing wrong if like
Yeah.
syntactically.
We're just implementing the concepts here, and the most important concept for Q and stacks is like understanding first input, first output, first in, first out, last in, first out. If you understand that part, everything is easy, everything is simple. And let's use the other while loop now. While now my stack is full. Stack till it's empty, I will run this. I will get it s.pop. So let me show you here. It's going to be, let's say I had 5 elements, right? First I dq'd, and then when I dq, it goes like this. When I use push X here, I will put 1 here, then 2 here, then 3 here, 4 here, 5 here. When I pop from S, 5 will pop up first, 4 will pop up first. Now it's like 5 is popping up, and now I will say, okay, I have the X element, Q dot NQ. Now Q was empty, and now I'm putting 5. This is my Q again. It was empty. 5 is here, 4 is here, 3 is here, 2, 1. Basically, it was like this, and there is no function to do that for now. And I used another empty stack to be able to reverse the functions, reverse the values in it. Any questions? Yes?
Do we have time to talk about recursion?
Yes, I mean, we will be here. I don't know if you want to be, like, continue, but like I will be here. We can continue with the questions. Like, I will be using a small stack question and then the recursion questions. So, from the left?
Does enq take something for the parameter?
Enq, of course. Oh, enq takes X. Sorry about that. I missed it. So, in recursion, like recursive functions, we used factorial. Everyone remembers it, and it was really difficult to implement it, and it was taking a lot of time. Now let's try to make it with just using one stack. So let's see how it goes. Let's name our function like long factorial. It takes the integer n and the stack s. So I'll say while, because I'm going to run a while loop, but let's say if I enter, let me explain it a little bit. If I enter number 10, what is going to do? I want my function to behave like this: 10 times, 9 times, 8 times, dot, 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 times another step, no, times 1. So I will be using a while loop when the n is greater than equal to 0, or greater than 0. Yeah, greater than 0. I will use my stack S here, S dot push, and here. And I will update n after that, n is equal to n minus. Wait a second, while if I say that, yeah. So what did I do here? I basically said, okay, this is my stack. I have the value 10. In the first step, put 10 here. Now n is equal to n minus 1. If I put it again, I will put 9 here, 8 here, something here, and then in the end, just 1. So I have all the values in a stack. All I need to do is just multiply them, right? So what I can say is, okay, let me assign some variable to result. Initialize it 1, because I'm going to multiply them, and the 1 is like not effective. While now I'm going to take the elements in the stack. Stack's length. Let's say I have a length function here greater than 0, or you can use the isEmpty function too. Like while s is not empty, we can run. You will update results. Result times. Can you guess what will come here? Yes, great. S.pop. Then what you'll return is no, return results. It will return the results and pop the other thing like 9, and then it will multiply by 8. So basically, this is another way of using, like implementing factorial with just using one stack.
I think the return is like, yeah, it needs to be out of the loop, but that's minor.
Yes.
Yeah. Yes. Anyway.
Yeah, it's not like.
The important part here is the concept. Yes, sure.
So, do you mind scrolling up for a second?
Sure.
So for the parameter of this function, I know it's stack ampersand s. Could there be a scenario where it would be a pointer or just a regular?
Yes. Yes, definitely. Like
So-
as long as like I need to reach that stack like with something. Could be pointer, could be just address value, could be like they can input it with another like 2 inputs with n and stack.
If it was just stack s, would that work? Would that also be
That would work. Yeah, that would work. This is just an example from a book. Again, you will when you receive the solutions manual for these review sessions, you will see it.
Yeah, no, I'm just curious because it was just stack s then.
Yeah, no, it doesn't matter.
Right, no.
The concept here is like you're using 2 while loops. In one of them, you're using the pop, and the other one push and multiplication. That's it.
I'm not sure if this is relevant, but like expanding off of that, like what would be the difference of using stack ampersand s and just stack s? Would there be any?
For this particular example, there's no reason to pass it by reference, but it would like if we had a different function where we needed to update it by reference, then we would do it. It just happens to be that the specific header had it, but.
Again, this is just for like practicing factorial with ADT functions. That's why like we don't really care what has been implemented before. And now, okay, sorry.
Explain the second while loop and what your technical goals are.
Second while loop. So in the first while loop, we just assign all the elements here.
Yeah.
You see, like 10, 9, 8.
Right.
So I basically expanded it, all the variables, all the factors in 10 to be able to get the final multiplication of that like series. So what I'm doing is I basically assign a value to result because I'm going to return a result value. I want to keep track of the result, and then I am emptying this stack with using pop function. So with pop function, the top value is 1. In the second while loop, the first thing I'm going to pop will be 1. The second thing, like when I run through again, I'm going to find 2 at the top. So results will be 2. And then it will be, the result will be 2, will be updated as 2. The next time I will pop 3. And the result will be 2 times 3, which is 6. The other time, result will be, I will pop 4. 6 times 4. See where I'm going?
Yeah.
Yeah. And then I basically empty the stack. And
Right, but like, well, how's that get the factorial?
the factorial is like what we are doing in factorial. We are multiplying all the values by going -1. Sure.
Is there a function length that just gives you the amount of items in the stack?
Yes, yes. Previously, for example, we previously used isEmpty. There was no isEmpty function, but we use isEmpty. Or we can still use here.
Should you be updating length every time then?
We can also use this.
When you pop something off the stack, they will be updated.
It decreases the length already.
You're the client of the stack, so you don't care about those. You
Yes.
only care about the functionality.
Okay.
Yeah, we are after functionality.
I think it's enough time for this. You could
Yeah, recursive functions. Now it's the recursive functions. Do you want to
I'll
go
stay
for
for the recursion.
yeah, this prime?
Let's ask. Do you guys have any function that you want to implement except palindrome?
I have palindrome too. I can help with the palindrome.
Okay, you'll do palindrome. Yes.
So like for these bigger research problems,
Yes.
what is the purpose of the helper? Why do we need it?
Okay. I think if you implement one,